Hello and welcome to our Calculus 1 final exam review. In this video, we're going to be going through all of the problems on the practice final exam for this course. Let's get started. Problem number 1. They want us to evaluate the limit using limit laws or facts. If an answer does not exist, we're going to write DNE. And our first limit says we have the limit as x approaches 2/3 of this rational expression. This can be done with evaluation, simply plugging in the 2/3 for all of the x's if we do not get an error or an undefined situation. So I plugged this expression into my Casio ClassWiz. You can see that I can plug it in exactly the way that it looks with all the fractions. And when I hit equals, I get an error, which indicates that the denominator is 0. We're having a divide by 0 error. And so in order to figure this out, to calculate the limit, we're going to have to do some algebraic manipulation. So let's blow this up and make it a little bit bigger, easier to see. What we notice in the numerator is that we do have the difference of squares. So we're going to try factoring the numerator. That's going to give us 3x plus 2 and 3x minus 2. And in the denominator, we have a trinomial with a lead coefficient. And the technique that I teach my students how to factor those is the 3R method. So the way that works, we're going to take the 18 and remove it, and instead multiply by the 10 at the back. That'll give us x squared plus 3x minus 180, and then we can try to factor this standard trinomial. We're going to have x and x. The signs are going to be different, and after a little bit of looking, we find that that is 15 and 12. 15 minus 12 is positive 3. 15 times negative 12 is negative 180. Now the second R, remember first we remove the 18, then we need to replace the 18 in front of each x, and the third R is reduce. 18 and 15 reduced by 3, 18 and 12 reduced by 6, and that's going to give us 6x plus 5, and on the other one we're going to have 3x minus 2. And so that's how this trinomial is going to factor. 6x plus 5, 3x minus 2. Now we can see that we do have a common factor that we can eliminate, and that's going to simplify the rational expression to 3x plus 2 over 6x plus 5. And now that we have that simplified, we're going to see if evaluation will work. And evaluating with our Casio ClassWiz, we can see that that will work out to be 4/9, and that is going to be the answer to this problem. So, making it official, we would say the limit as x approaches 2/3 of 3x plus 2 over 6x plus 5 is 4/9, and that's going to do it for the first problem. Problem number 2, we have the limit here as x approaches infinity, again of a rational expression. One of the most effective techniques here is to divide top and bottom by the highest power of x. And so what I'm going to do is I'm going to divide top and bottom by x squared, since that is the highest degree of the variable. And that's going to give us 9x squared over x squared will simplify to just 9, minus 4 divided by x squared is going to stay a fraction. In the denominator, 18x squared divided by x squared is just 18. Plus 3x over x squared would be 3 over x reduced, minus 10 over x squared stays a fraction, And now what we can do is we can say, okay, what's going to happen if x gets infinitely large? Well, these fractions, if x gets infinitely large, a fraction itself gets infinitely small if the denominator gets infinitely large, but the numerator doesn't change. So all three of these fractions are effectively going to go to 0, which will leave us only the 9/18. And so we can say that this answer is going to be a half. And that's it for problem number 2. Next, number 3, we have the definition of derivative. We want to find the limit as h goes to 0 of the difference quotient given this function. And the first step is to replace every x in f of x with x plus h. So that'll give us x plus h quantity squared minus 1. Next, we need to subtract the original function, which is just x squared minus 1. And that is all divided by h. And don't forget that we need to write the limit as h goes to 0 every step until we can let h go to 0. And no, it's not now, because if I let h go to 0, the denominator would be 0, and that's undefined. So here we go. Next step, we're going to have the limit as h approaches 0, and we need to do the FOIL method here. So foiling x plus h is going to give us x squared plus 2xh plus h squared minus 1, and then this minus needs to distribute all over h. Now notice in the numerator that x squareds will cancel and the 1's will cancel. And if you notice, all of the remaining terms in the numerator have an h. So now we're going to say the limit as h approaches 0, factoring out the h, will give us 2x plus h all over h. And now these h's will reduce out. So now what we can do is we can say, okay, now we can let h go to 0 since we don't have the divide by 0 problem, meaning that this guy's going to go to 0, and the answer is simply going to be 2x. And that's going to do it for this problem. Next, given that f of x is the square root of x, we need to use the definition of derivative to find f prime of 2. So this time we're going to use the definition of derivative that says the limit as x approaches our value, which in this case is 2. If you remember, the formula for that said the limit as x approaches a, and a was the number we're concerned with. So we're going to say the limit as x approaches 2 of f of x minus f of a all over x minus a. That was the formula. Now let's go through and replace the pieces with what we've got. F of x is the square root of x. F of a, where our a is 2, would simply be the square root of 2. And then in the denominator, a again is 2. So this is our limit. We're looking for the limit as x approaches 2. And we could do direct substitution if we didn't get a divide by 0 error. And so here, again, we're going to have to do some algebraic manipulation so that we can let x go to 2. So what we're going to do is we're going to take the numerator and the denominator, and we're going to multiply by 1. Okay, not really, but yes, really, 1. Meaning that we're going to multiply by something over itself, which is effectively 1, and our goal is to get rid of the radicals in the numerator. So to do that, we want to multiply by the conjugate. That is the same radical stuff with the opposite sign. We have to do that to top and bottom, and then we're going to get to do the FOIL method. Okay, here we go. Square root of x times square root of x would be the square root of x squared, which is just x. On the outside, we get a positive square root of 2x. On the inside, we get a negative square root of 2x. Notice that those terms are equal but opposite. They will cancel. And last, negative square root of 2 times square root of 2. We have a negative times a positive, which gives us a negative. Square root of 2 times square root of 2 is square root of 4, which is 2. I'm going to leave this factored. X minus 2 times square root of x plus square root of 2. I don't recommend that you FOIL the denominator. And here's why. If we simplify, having the limit as x approaches 2, now the numerator is simply x minus 2. And the denominator, do you see it has a common factor with the numerator? And so what we're going to be able to do here is reduce the fraction. The x minus 2's will divide out and make 1. Really, there's a 1 up top. And then at this point, we should be able to let x go to 2 right here. And so that would give us 1 over square root of 2 plus square root of 2. Those are like terms. So we can add those and get 2 square root of 2. And there's our answer for that problem. Next, number 5, it says, how would you define f of 0 to make f continuous at 0? And this means we have to know what it means to be continuous. Remember, there were 3 conditions that had to be met. The limit as x approaches a, in this case 0, of the function has to exist. F of 0 has to exist. And the third step was that the limit has to equal the function value. And so where this fails in the continuity is that f of 0 does not exist. If you try to evaluate at 0, you're going to get a divide by 0 error. And so the function is actually undefined at 0. And so then what we're going to do is we're going to try to figure out what we would let f of 0 be so that it is continuous. Well, looking over here at our criteria, we know that the limit as x approaches 0 has to equal f of 0. So we need to know what the limit is, or if it exists at all. That would definitely be a criteria that has to be met. And once we know if it exists and what it is, then we will know what to set f of 0 to be. Now, to find the limit of this function, we're going to set this up. The limit as x approaches 0, negative 2 sine of 2x over x. If you're not exactly sure how to maybe approach this, algebraic manipulation or other techniques to avoid the divide by 0 error, your fallback method, your safety net, so to say, is to make a table. So what I'm going to do is I'm going to make a table of values that approach 0 from the left and right. And then I'm going to see if I can determine what the limit is as we get closer to 0. So let's do about 3 numbers. I think that's the way we normally did it in class. From the left, negative 0.01, and from the right, 0.01, and then make those get a little bit bigger. Maybe negative 0.1. Maybe negative 0.5, and then those need to be symmetric. So over here, this would be 0.1, 0.5. And then all we have to do is evaluate the fraction for these predetermined values and see what the y values are. So just a reminder that when you're calculating with your scientific calculator here, you do need to be in radian mode. Notice on my ClassWiz, I am able to input that just the way it looks. Here I've replaced the x's with negative 0.5, and we're going to get negative 3.366 rounded. And then with your calculator, if you have the ClassWiz, it's super easy to simply scroll back and delete the negative signs. And then without having to retype the whole thing over again, you can get the positive 0.5 value. And we see that that is symmetric. So again, negative 3.366 rounded. And that indicates that these other values will probably be symmetric also. So let's adjust. Again, wanting to point out with the Casio that it's easy to go back and edit what you previously input. And we can get our positive 0.1. And then remember, that's probably going to be symmetric with your negative 0.1, but I would suggest that you evaluate it just to make sure. Negative 3.973. And then one more time. Again, simply go back. This time we're going to input a 0 to do our 0.01. That's the positive. Negative 3.997. That's actually going to round to negative 4 if I go to 3 decimal places again. So I'm just going to say rounded to 3 decimal places, that would actually be negative 4. And that right there indicates what our limit is. And so that in turn is what we need to define our function as. So f of 0 would need to be defined as negative 4 so that the limit exists, the function value exists, and the limit equals the function value. Next, problem number 6. If an equation of the tangent line to the curve y equals f of x at the point a equals 4 is this equation. They want us to find f of 4 and f prime of 4. Okay, so here's one of the things that we know. The standard form of the equation of the tangent line, if you use point slope form, y minus y1 equals m x minus x1. If we use the point slope form and want the equation of the tangent line, then that's going to be x1 is whatever number you want. Say a, y1 would be the function value at a. So here you've got your x and your y coordinate depending on whatever number you choose for a. The m, remember the slope of the tangent is the derivative at that value that you've chosen, so f prime of a. So knowing this formula, we can manipulate this into slope-intercept form and then line it up with the equation we're given. So I'm going to distribute the f prime of a and bring over the negative f of a. That's going to give me f prime of a times x minus f prime of a times a plus f of a. Now, let's make a note here that here's our x, and so this must be our slope. F prime of a times a, that's a value, that's a number, and so is f of a. So this entire expression here is b, y equals mx plus b, and here we know those values from the given equation. So we can say that, first of all, every a in this situation can be replaced with 4. That's what our value is. And then we can say f prime of 4, which is the slope, is the slope of our equation, which is 4. Notice that that is one of the pieces they ask us to find. F prime of 4, that's done. And now that we know what that is, we can replace f prime of 4 with what we know. Okay, so going this way, that's going to be negative 4 times 4 plus f of 4. All of this has got to equal b, which is, in this case, negative 7. And then we have an equation here we can solve for f of 4 and get the other piece they asked for. Negative 4 times 4, negative 16 to the other side makes a plus 16. And then we can see that f of 4 is 9. And that's going to do it for this problem. Next, number 7, find the number c that satisfies the conclusion of the mean value theorem on the given interval. So here we have the function f of x equals 2 square root of x on the interval from 0 to 9. And what the mean value again says, it says that somewhere along your function on a given interval, there will be a point called c where the slope of the tangent at c is the same as the slope of the secant containing the endpoints of your interval. So the first thing we need to do here is we need to find the slope of the secant. And then we will simply find the value c that gives us the slope of the tangent to be the same value. Okay, so here we go. Finding the slope of the secant, just like we find the slope of any line, we need 2 points. And in the numerator, remember that's y2 minus y1, but y is f of x, and here we would have f of 9. That's going to be f of 9 minus f of 0, those are the endpoints of my interval, over 9 minus 0. And then we need to calculate that slope. So f of 9, plugging a 9 in, is going to give me 3 times 2, which is 6. F of 0, again, that's going to be square root of 0, which is 0. 0 times 2 is 0. All over 9 minus 0 reduces to 6 over 9, which is 2/3. So this is our target slope. This is what we want the slope of the tangent to be to satisfy the mean value theorem. Now, how do you find slope of the tangent? Well, you need the derivative. And so we're going to have to calculate f prime of x. The best way to do that in this case, since we have a radical function, is we're going to rewrite that as 2x to the 1/2 and then use the power rule. So we say the 1/2 times 2 is 1. X to the 1/2 minus 1 is negative 1/2, which is the same as 1 over x to the positive half, which is the same as 1 over square root of x. So this is our derivative. Remember, we need this to be equal to the slope of the secant. Derivative is the slope of the tangent. Again, we need the 1 over square root of x to equal 2/3. So let's solve for x. Cross multiply. We're going to get 2 square root of x equals 3, and divide by 2. Square root of x is 3 over 2, and simply square both sides. And so here we can see that our value of c, remember that's a value of x within the interval, is going to be 9/4. And it might be nice to check and make sure that that value that you get is actually between 0 and 9. And that's going to do it for that problem. Next, number 8. Find the slope of the tangent line to the following equation at the indicated point. Slope of the tangent. That means we're going to need the derivative. And here they have given me a rational function with trig functions involved. And this looks rather nasty. So what I'm going to do is I'm going to see if I can manipulate this equation into something a little easier to take the derivative of. First of all, notice the denominator is a monomial. It's one term. And so I'm going to separate this into separate fractions. 4 over secant x minus tangent x over secant x. And then I'm going to remember that secant x is 1 over cosine x. So if I replace secant x in both of these cases with 1 over cosine x, I'm going to get division with fractions, which means I'm going to need to do the KCF. We're going to keep, change, flip. And then this first fraction is going to become something really nice. That's going to just simply become 4 cosine x. Now again, tangent, I can replace tangent with sine x over cosine x. If I take and multiply by the reciprocal of 1 over cosine x, then that's going to give me cosine x over 1. Notice what happens here to my cosines. And again, that simplifies really nice to just sine of x. Now this equation is going to be much easier to take the derivative of. Here we go. Y prime is the derivative of cosine x is negative sine x. Remember that the coefficient here just comes along for the ride. And then we need to take the derivative of negative sine x. Well, the derivative of sine x is cosine x. And here the negative just gets attached to negative cosine x. So there's our derivative. And now what we need to do is, it says we need to find the slope at this point, which means that we need to evaluate all of the x's at pi over 4. So I would say the slope of the tangent is negative 4 sine pi over 4 minus cosine pi over 4, and then plug that into our calculator. And as you can see here, I've input that in my ClassWiz. Just a reminder that this needs to be in radian mode since those angles are radian. And also notice that the ClassWiz gives us our exact answer in simplest radical form, which is freaking sweet. So our answer here, negative 5 square root of 2 over 2. And that's going to do it for this problem. Next, number 9, find the equation of the tangent line to this curve at this point. So our equation y equals 7x minus x squared at the point 2, 10. Now remember, to find the equation of the tangent, we first need to find the slope of the tangent. And that means that we're going to have to find the derivative. So y prime is, using the power rule, the derivative of 7x is 7. The derivative of x squared is 2x. There's our derivative. And then to find the slope of the tangent, we need to evaluate at our given x, which is 2. 7 minus 2 times 2 is going to give us 7 minus 4, which is 3. So there's the slope of the tangent. And now for the equation part, we're going to use the point slope form. Y minus y1 equals m x minus x1. Our y1 is 10. Our slope is 3. And our x1 is 2. And we're done. But you probably don't want to leave it in point slope form. Probably want to write that in slope intercept form. So let's go ahead and do the distributive property and bring the negative 10 over and simplify. 3 times x is 3x. 3 times negative 2, negative 6 plus 10. Negative 6 plus 10 is 4. And we're done. That is the equation of the tangent line to our function at the given point. Next, number 10, find the equation, this time of the normal line to y equals x squared minus 6x at the point 1, negative 5. This is going to work exactly like number 9, except when we find the slope of the tangent, we will then need to convert it to the slope of the normal. All right, first, slope of the tangent means that we're going to have to find the derivative. And the derivative of x squared is 2x. The derivative of negative 6x is negative 6. And then the slope of the tangent is going to be this expression, 2x minus 6, evaluated at 1 in this case. 2 times 1 minus 6. That's going to be negative 4. Now remember, this is the slope of the tangent. Now to get the slope of the normal line, we need to take this slope and flip it and change the sign. Because if you remember, the normal line is perpendicular to the tangent line. So once we get our tangent slope, we need to make it perpendicular. Perpendicular line, flip and change the sign. So there is the slope we're going to use. And then we simply go to the point slope form. Y minus, y1 minus a negative makes it a plus, equals m, slope of the normal, x minus, x1, and we're done. If you want the answer in point slope form. Probably going to want that answer in slope-intercept form. So let's distribute and move the 5 over. And we're going to get 1/4 x minus 1/4 minus 5. And then if we combine like terms, that's going to be minus 21/4. And that is the answer we're looking for right there.